Glad you're back. This is part 4 of the Exam 3 review, and in this part we're going to look at application problems. This kind of problem is called a work problem, where you have two people working, and if they each do the job alone, it's going to take longer than if they do it together. Now the equation for figuring out the kind of different times they're asking for is 1 over T1 plus 1 over T2 equals 1 over the big T. And the big T is the time that they would take if they did it together. So let's look at this problem. Peter and Mary are laying a tile floor. If they work alone, Peter can do the job in 20 hours. But if they work together, they can complete it in 12 hours. So the question is, how long would it take Mary if she were working alone? So what we're going to do is we're going to plug in these values, which are Peter's. We're called T1 is Peter's time. T2 is Mary's. And T is together. So what are we given? Well, let's write our equation again. So let's plug in the values. T1 is going to be Peter's time. Peter's time is 20 hours. So we have 1 over 20 here. T2 is Mary's time, and we don't know what Mary is doing for her time, so we're going to leave it as T2. That's what we don't know, and that's what we need to find. And then if they were working together, the problem says they could do it in 12 hours, so we're going to put 12 for capital T. Alright, if we can find the least common denominator, we can make this problem, we can make the fractions go away, and I know you guys are all in favor of that. So the least common denominator, well, we have 12, and we have T2, and we have 20. So 12 equals, remember, break it down to primes. So we have 2 squared times 3, T2, and 2 squared times 5. We circle one of the T2 squares, and then we circle everything else. And the least common denominator is going to be 2 squared, which is 4, times 3, which is 12, times 5, which is 60, times T2. Okay, so we're going to multiply everything by 60 T2 on both sides of the equation. And as a fraction, that would be 60 T2 over 1. So this is what this is going to look like. Distributing the 60 T2, we get 60 T2 over 20 plus 60 T2 over T2 equals 60 T2 over 12. 20 goes into 60 3 times. The T2's cancel. 12 goes into 60 5 times. So we're left with 3T2 plus 60 equals 5T2. That is an easier thing to work with. So you guys like moving things to the left, so I'll do that. We're going to subtract 5T2 from both sides, and that gives us negative 2T2 plus 60 equals 0. And then we're going to subtract 60 from both sides, and we get negative 2t2 equals negative 60, and then we divide both sides by negative 2, and we get t2 equals 30. So that tells us that Mary would take 30 hours to complete the project on her own. This is a problem of converting distances from what you see on a map to their actual distances. And so the way we do this is we use proportions. So on a map of the U.S., the distance between Seattle and Durango is represented with 4.125 inches. In actuality, the distance between them is 1,238 miles apart. So that tells you that the 4.125 inches corresponds to 1,238 miles. So now you could tell, if you're given another distance, you could tell how many inches it will look like on the map. And that's what they're asking. They say, what measure on the map in inches would represent the distance between Chicago and El Paso, which are 1,606 miles apart. Let's organize our information. We have the distance from Seattle to Durango, and then we're asked about the distance between Chicago and El Paso. And we're considering that distance in miles as well as inches. So let's set up a table here. Seattle to Durango, we know, is represented with 4.125 inches, and it's represented with 1,238 miles. The Chicago to El Paso distance, we don't know how many inches, but we can put them as 1,606 miles. Now you can set up your proportion in one of two ways. You can compare your miles for one place over your miles for the other to your inches for one place over the inches to the other, or you can do it 1238 over 4.125 equals 1606 over x, or you could put the inches on top. Let's do it the way it looks. It looks like this. And like I said earlier, whenever we see this, we want to cross multiply. Well, in this case, that's what you do. We're going to cross multiply 1238x equal to 1606 times 4.125. And then to solve for x, we're going to divide both sides by 1238 to get x by itself. And then we're going to pull out our calculators, and we find that x is 5.35117 and so on miles apart. Now the problem doesn't tell us how far to round it, but since the other inches was to the thousandths place, 4.125 is to the thousandth place, let's take our answer to the thousandths place too. And this is tenths, hundredths, thousandths, but we need to write down one more digit so we know if we need to round or not. So I've written down to the 10,000ths place, and that's not the answer yet. So we look at the thousandths place. You can draw a line between the 10,000ths place, and if the digit in the 10,000ths place is less than 5, you don't round. So we're not going to round. We're going to just leave it as 5.35. So 5.35 inches is the solution to the problem, and it represents the distance on a map between Chicago and El Paso. A VAT problem is like a work problem, only you have stuff coming in and stuff going out, and that means there's going to be a subtraction somewhere. So I always like to draw a picture. You have a vat of acid, and it's filled by this inlet pipe in 10 hours, but it's emptied by an outlet pipe in 20 hours. So what it's saying is, if this were closed, this would fill in 10 hours. If there was nothing coming in, this would empty in 20 hours. But what if they're both going? What if stuff is coming in and acid is also going out? So what you would say here is the time it takes to come in, and I'm going to call it in, minus the time 1 over the time it takes to leave equals the total time if both were open. So now this is like a work problem, except you have a subtraction involved. So we know that it takes 10 hours to come in, so we can just write 1/10, and it takes 20 hours to empty. That's 120. That's our equation that we're going to solve. So again, we're going to find the least common denominator, which in this case is pretty clear. It's 20t. So we're going to multiply everything by 20t. And so what we get is 20t over 10 minus 20t over 20 equals 20t over t. So we can see that 10 goes into 22 times, the 20's there cancel, and the t's over here cancel. So you have 2t minus t equals 20. So that tells you that the time it takes, if both are open, is 20 hours. That means it would take 20 hours to fill the vat if both pipes were open, whereas if the exit valve was closed, it would only take 10 hours. This is what we call a current problem, and it involves the formula distance equals rate times time. Now you see that I've given the formula time equals distance over rate, and this is why. If distance equals rate times time, and we divide everything by r, you see that distance over rate equals time, which is the same as this formula. So we have a distance, rate, and time with the current and against the current. In still water, a boat averages 9 miles per hour. It takes the same amount of time to go 26 miles downstream with the current as 35 miles upstream against the current. What is the rate of the water's current? So let's call C, let's let C stand for current. Okay, in still water, the boat goes 9 miles per hour. So its normal rate is 9 miles per hour. If it's going with the current, it's going faster. The current is adding C to it, so it's going at a speed of 9 miles per hour plus whatever the current is. When it's going against the current, that means it's being slowed down, so the 9 miles an hour is losing speed by C. So it's 9 minus C. Okay, let's look at the problem and see what we know about distance. We know that downstream it's going 26 miles, and upstream it's going 13 miles. Well, downstream is with the current, so that's 26, and upstream is against the current, and that is 13. And we know that the time is the same in both cases, although we don't know what the time is. But the time is the distance over rate, and that's why we use the formula in this way. So again, let's put parentheses around our binomials, and the time is going to be the distance with the current over the rate. It's also going to be the distance against the current over the rate. So since we know that the two times are equal, that's what we're going to go with. That means the 26 over 9 plus c is equal to 13 over 9 minus c. So now you have an equation you're used to solving. You can subtract from both sides the 13 over 9 minus c. So you have 26 over 9 plus c minus 13 over 9 minus c equals 0. The least common denominator is going to be 9 plus c times 9 minus c. And so we know that c isn't going to be able to be negative 9 or 9. So our domain is c such that c doesn't equal negative 9 or 9. And in fact, the current isn't going to be a negative number of any kind. So now we multiply, we go through this again and do what we did before, or let's do it in such a way that if we multiply everything by the least common denominator, what happens? This is the same thing we've been doing, but it looks a little differently. So we write 9 plus c times 9 minus c over 1 times 26 over 9 plus c minus 9 plus c 9 minus c over 1 times 13 over 9 minus c equals 0. And then let's cancel. The 9 plus c's go away over here, and we're left with 26 times 9 minus c. And in the second term, the 9 minus c's cancel, and we're left with subtracting 13 times 9 plus c equals 0. So we have to find out, we have to distribute the 26 and the negative 13. So in the first case, we get 234 minus 26c. In the second case, we're going to put brackets around the 13 times 9 plus c so that that minus doesn't throw us. And inside the brackets, we get 117 plus 13c. Okay, so let's distribute the negative sign, and that gives us 234 minus 26c, and we can do it this way, change the signs of everything inside, plus negative 117 plus negative 13c equals 0. So now we have 234 plus negative 117, which gives us 117. So we have 117, and then we have minus 26c minus 13c, so that gives us minus 39c equals 0. And it just so happens that 39 goes into everything, so we pull out the 39, and we're left with 3 minus c equals 0. So we divide by 39, and we get 3 minus c equals 0. Negative c equals negative 3, and divide by negative 1, and you get c equals 3. So the current is 3 miles per hour, and it is not one of our disallowed values, so that is in fact the answer. Okay, this is another distance equals rate times time problem. A small plane travels from Gary, Indiana to a national park that has a landing strip. It averages 200 miles an hour. On the return trip, the average speed is 300 miles an hour. If the total traveling time is 4 hours, how far from Gary, Indiana is the park? So we need to remember the formula: distance equals rate times time. And if you have trouble remembering that, think about it this way. If your car goes 30 miles per hour on a certain street, that means it's going 30 miles for every hour. And that tells you how fast it's going, which is the rate. Well, miles is distance, right? And hours is time. So you have distance over time equals rate, which is, if you multiply both sides by t, you get distance equals rate times time. So if you forget the formula, think about, what does 30 miles per hour mean? It means the rate you're going, and miles is distance, and time is hours. So we set up another table, and this time we're going to say rate times time equals distance. Doesn't matter, you can put it in any order, but rate and time involve information you're given, and distance is what you want to find, so that's why I put it in this order. So our upper row is Gary to the park, and our lower row is the park to Gary. So what do we know? We know that it's averaging 200 miles when it's going from Gary to the park, 200 miles per hour. So the rate from Gary to the park is going to be 200. On the return trip, it's averaging 300 miles per hour, so the rate on the return trip is 300. The total traveling time is 4 hours. Well, that's only one time. Where do we put it? It's the total traveling time. So let's think of it this way. The time that it takes to go from Gary to the park, we don't know, so we're going to call it T. And the time that it takes to go from the park to Gary, we don't know, but we know that the total time is 4 hours, so if we take 4 hours and subtract T, we'll get the time that it takes to go to the other way. So if you add your times together, your T's are going to cancel and you're going to get 4 hours, which is what you want. And we know that distance equals rate times time, so we don't know what the distance is, but we know it's 200 times whatever the time is, and in the other direction it's 300 times 4 minus the time. And we also know that the distances are equal. So we can write the equation 200t equals 300 times 4 minus t. So let's go ahead and simplify the right side. And we can move everything from the right on the left. We're going to add 300t and subtract 1200. And I didn't leave myself enough room. So on the left we're going to have 500t minus 1200, and on the right we're going to have 0. So we can pull out the common factor 100 and we get 5t minus 12 equals 0. And if we divide both sides by 100, we get 5t minus 12 equals 0. So then we add 12 to both sides and we get 5t equals 12. So t equals 12 fifths. So you can write it as 12 fifths, or you can take your calculator and find out that 12 fifths is 2.4. So you could write 2.4 hours. It just depends. If they don't specify, then you can do it either way. So that's the time it takes to go in one direction. Now we need to know the distance, and the distance is the rate times the time. So let's look at our chart again to get a feel for what we're talking about. And we found out that the time here is equal to 2.4 hours. And we also know that the distance is 200 times the time. So we can find distance by multiplying 200 times 2.4. And that's going to tell us that the distance between Gary, Indiana and this national park is 480 hours. Now you can check this because you know that the distance going from Gary, Indiana to the park is the same distance from the park to Gary, Indiana. And you're told here that the distance from the park to Gary, Indiana is 300 times 4 minus t. So ask yourself, if you plug in 2.4 for t, does 300 times 4 minus t equal 480? And if it does, you've done the problem right. So let's do that. 300 times 4 minus t, which is 2.4, is 300 times 1.6, and that equals 480, just like we were hoping it did. So what you want to remember on this problem is after you've solved your first equation and you've gotten that t equals 2.4 hours, you're not done, because what they're asking for is how far from Gary was the park. In this problem, we're told to solve, and we also have an equal sign, so that means we have to find a value of x that makes this equation true. Before we begin that, when we have fractions, we have to make sure we're not going to have a denominator equal to 0. And in this case, we have 3x, 24x, and 24. The only thing that can make any of these denominators 0 is if x itself equals 0. So we can start out by saying x cannot equal 0. And so our domain, not that we're being asked that, but our domain is such that all real numbers will work except that x cannot equal 0. So that's how you write domain and set theory. Now we're going to solve, and when we add fractions we have to find a common denominator. So we have denominators of 3x, 24x, and 24. So what is the common denominator? Well, if you look at the numbers, you can see that everything goes into 24. So our least common denominator is going to have 24 for the number and then x for the variable. So we need to have a fraction that we can multiply negative 1 over 3x by to get something over 24x. We'll make room for that. And then in the second fraction, we already have 24x as a denominator, so we won't have to do anything to it. But in the third fraction on the other side, we will. So let's look at the first case. We're going to multiply negative 1 over 3x by something to make it 24x. And so if we multiply 3x by 8, we'll get 24x. So we need to multiply that fraction by 8 over 8. And on the other side, we already have 24, so to get 24x, we have to multiply by x over x. And like I said earlier, we don't have to do anything to this fraction because our denominator is already 24x. So that gives us negative 8 over 24x plus 5 over 24x equals negative 7x over 24x. Now, at this point, if you want to, you can actually get rid of all of the denominators. We don't need the denominators now that they're all the same. We've already decided what x cannot be up here, and that's what our denominators told us. Or you can keep working with it a little bit by combining your numerators. So, and bringing over that negative 7x over 24x. So let's add that to both sides. So now we have something equal to 0. We combine our numerators, and then we add together our like terms, and we get negative 3 plus 7x in the numerator, 24x in the denominator equals 0. And as I said, we can discard the denominator at this point. It's just like if we multiply both sides by 24x, 0 times anything is still 0, so we'll get negative 3 plus 7x equals 0. So now we have negative 3 plus 7x equals 0, so adding 3 to both sides, we get 7x equals 3, and divide both sides by 7, and you'll find that x equals 3/7. So x equals 3/7 is the number that will make this equation true. You have to go back to the beginning, and when we do, we see that we are prohibited from having x equal to 0, but we found that x equals 3/7, so we don't have to worry about that. So our final solution is set. It consists of 3/7. Here's another problem where we're solving, and first we have to find the denominators that are not allowed so that when we get our solution we can compare and make sure our solution is allowed. So we need to find a least common denominator. We write all the denominators down. The first two are already factored. When we factor the third, we see it's x plus 7 times x plus 3, which is handy because now we have x plus 7 here and x plus 3 here. So in order to make this fraction have this as a denominator, because this is our least common denominator, then we need to multiply this fraction by x plus 3 over x plus 3, and this one by x plus 7 over x plus 7. And this one we just rewrite what is already there this way, but we don't have to multiply by anything because it's already the least common denominator. So let's always put parentheses around our binomials. We're going to multiply by x plus 3 over x plus 3 here. And we're going to multiply by x plus 7 over x plus 7 here. And notice that when we do that, we get new fractions, all of which have x plus 3 times x plus 7. Doesn't matter if the order's switched. You can switch the order in multiplication. So now let's go ahead and multiply out our numerators. We have x plus 3 for our first term plus 1 times x plus 7 all of that over x plus 7 and x plus 3. And on the right we have 4 over x plus 7 and x plus 3. Now, before we cancel out our denominators, we need to examine our least common denominator and decide what values of x make that denominator 0. So if x equals -7 or if x equals -3, that makes the least common denominator 0. So we write that in set theory that x can include all values such that x does not equal -7 or -3. Having done that, we have no more need for our denominators, and since they're the same, we can cancel both of them on either side. So now we just combine like terms in our numerators, and then we solve for x. First we'll subtract 4 from both sides to get 0 on the right, and then subtract 6 to get 2x equals -6, divide by 2, and we have x equals -3. But we're not done because we have to go back and see our domain says that x cannot equal -3. And since that's the only solution we found, that means that this solution won't work, and there is in fact no solution to that problem. In this problem, we're going to use the rules that we know very well, but we don't have the variables that we're used to, which is either 1 or 2 variables. We have a bunch of variables, and we are solving for p. And what that means is we want to end up with p equals something. So we need to isolate p. Now you're used to seeing your variable on the left. If you want to, you can go ahead and rewrite this equation with your p on the left. So all you're doing is switching sides of your equation. Now you need to get p by itself, but before that you have to understand that p is contained in the parentheses with p plus a. So let's get rid of all of this. To move a fraction over to the other side, you multiply both sides by its reciprocal. So on the left we have q times p plus a equals, and then 7 over 1 is the same thing as 7, so we have 7a. So far so good. We've cleared the fractions because the 7's cancel. Okay, so now we want to get rid of this q. So we're going to divide both sides by q. And the q's cancel over here, and we're left with p plus a. We no longer need the parentheses because that's all there is. So what's the last step? There's only one more step to get p by itself on the left, and that is that you subtract a from both sides. And voila, you are done. Congratulations, you've completed the Exam 3 review. My recommendation is that now you go work some practice tests, identify the areas you still have problems with. You could use the study plan at that point to work on those areas. Follow the instructions on how to use the study plan, which is in course documents. If you have any questions, send me an email. Good luck on the exam.